Alright folks, welcome back. In this video we're going to practice reducing roots and radicals, because we saw that not every number is a perfect square. For example, 72. 72 is not a perfect square, but we can still ask ourselves, what is the square root of 72? What number multiplied by itself makes 72? So 72 is not a perfect square, which means that number we're trying to find isn't a whole number. Okay, but it's a number and just a little bit more, and we need to figure out what that number and a little bit more is. Now, in order to do that, we need to reduce this radical. Now, what does it mean to reduce a radical? That means to break it down to the point that there are no more perfect squares hidden inside. And when I mean hidden inside, what do I mean? Well, let's take a look at 72. Tell me, what numbers multiply together to make 72? Ideally, let's think about numbers that are perfect squares. Is there a perfect square which can be used in a multiplication problem to make 72? Yeah, there's quite a few, right? We could do 36 times 2. 36 times 2 definitely makes 72. So let's rewrite 72 as 36 times 2. So what did I do? I just rewrote this radical as 36 times 2 instead of 72. Now, this is what I mean by having a perfect square hidden inside the radical. 72 is really a perfect square times another number. Now, the cool thing about radicals is there's this thing called the product rule. And the product rule allows us to break radicals up if there's multiplication inside. So what this means is the square root of a product, meaning 36 times 2, is equal to the product of two square roots. Meaning I can break 36 times 2 all in one radical up into the square root of 36 times the square root of 2. And now this is valuable because I know that 36 is a perfect square. 36 is a perfect square. 36 is equal to 6 times 6. So the square root of 36 is 6. So this is equal to 6 times the square root of 2. And now I can ask myself, is there another number that is a perfect square that goes into 2, which is the only other number left in the radical now? Since there are no numbers that are perfect squares that go into 2, that means that this is my reduced radical. Okay? 6 times the square root of 2 is the square root of 72. Now, that being said, there are more than one ways to do this radical. If I look at the square root of 72, the first number that came to mind for me was 36 times 2, but there are other numbers which multiply together to make 72. For example, 72 is the same as 9 times 8. So this is equal to the square root of 9 times 8. Once again, I can use my product rule. And the product rule tells me that if I have a product inside of the radical, I can make that radical into the product of two radicals, namely the square root of 9 times the square root of 8. Now the square root of 9 is a perfect square. It's 3 times 3. So the square root of 9 is 3. And we bring down that square root of 8. And once again, we need to ask ourselves that question, is there a number, specifically a perfect square, that goes into 8? The answer to that is yes, right? We can write 8 as 4 times 2. So let's rewrite everything here. 3 times the square root of, instead of 8, we're going to do 4 times 2. Once again, I can use my product rule, which tells me that if I have a product inside of a radical, I can break that up into the product of two radicals. So this is equal to 3 times the square root of 4 times the square root of 2. I took this 4 times 2 inside the radical, and I made it square root of 4 times the square root of 2. Once again, 4 is a perfect square. Square root of 4, what number times itself makes 4? It's going to be 2. So this is equal to 3 times 2 times the square root of 2, which is equal to 6 times the square root of 2. Once again, the same exact answer. So there are multiple ways in which we can do these reducing radical problems, right? We can reduce radicals in a number of ways, but the important thing to remember is you know you're finished, you know you have reduced your radical if there are no longer any perfect squares in disguise underneath the radical, if there are no more perfect squares that can go into the numbers that are under the radical. So check back in, guys, for more examples. I'll see you next time.